The world is changing rapidly. From the era of transistor and animal-driven vehicle, we have entered into the reign of LEDs and automobiles. And for all this development, the world has always been extensively dependent on electronics. Be it your mobile or computer or the router, inside every device there is a circuit board that is executing all the operations that you instruct. These boards are electronic circuits made of sophisticated electronic components and their wiring. The wiring comes printed in the form of a board, so these are called printed circuit boards or PCBs. As we know, to make a circuit working, we need components and copper wires. So for crude testing purpose, we can use breadboard or Vero board. But the PCB has certain advantages when you need a compact design, low noise performance, especially for sensitive electronics, high-speed system where transmission line effect is a big factor, and of course, PCB fabrication is a highly automated process. So, for mass production of a device, PCB designing is a must. From a system requirement to a PCB testing, there are several important stages such as circuit design, simulation for performance validation, PCB layout design, exporting Gerber, fabrication process, breadboard test, component placement, and finally, test setup. This is a tutorial series which will discuss all these stages in its course. However, this video will concentrate on PCB and its structure. A PCB is a board made of some insulation material on which we have contacts, roots, and vias. There are several insulation material with varying dielectric constant used as core material of PCBs. All the contacts, roots, and vias are made of copper. This is like our houses, roads, and flyovers on the face of Earth. Contacts are locations where we place a component or connector. A contact has a gold or tin plating on copper to avoid oxidation before component placement. Soldering is a technique used to fix components on pads. The roots need no plating, so they are laminated by some insulating material. It protects the copper routes from getting oxidized and from scratches. Today, PCBs are densely packed for compactness. There are many roots crossing each other. To make such routing possible without overlapping, we need multiple layers and bridges. Vias are such bridges. They connect different layers. In general, a PCB has a top and a bottom layer where you can place components. Then, depending on complexity of your design, you have to add extra layers. Their stacking up is like copper layer top insulation, inner copper layer 1 insulation, and so on. And finally, copper bottom layer. On the top and bottom layer, we need to laminate all the copper roots and expose contacts for gold plating. For this purpose, there is solder mask layer. And for writing different things such as name of the PCB or reference name of the components, we need silk screen layer on the top and bottom. This knowledge of layers will be important when we discuss PCB layout design. As we have said earlier, PCB fabrication is an automated process. A fabricator requires layer information in a specific set of files called Gerber files. To make the automation possible, there are several design softwares which generate Gerber files. We will use National Instruments Design Suite for the tutorial series. The reasons for that are: this software is free for design up to 6 layers. It has best user-friendly GUI and facility of very good simulation tools. This is it for today. In next episodes, we shall get into NI Design Suite for circuit design, simulation, and PCB layout design. So guys, subscribe to my channel to stay in touch and get the latest updates.